If a body has a line of symmetry, the center of mass will lie on this line. This fact is very useful. For example, the center of mass of a circular lamina is at the center of the circle. Since the center of mass is on this x-axis of symmetry, and they all meet at the center. Students, welcome again to my channel, DNA.12 Education, Center of Mass Composite Lamina, Part 3. Okay students, today we are going to discuss several questions how to find the center of mass of composite lamina. Okay students, I want to give you example 1. Students, look at this object. This composite lamina consists of 3 shapes: rectangle, triangle, and triangle. How to find the center of mass of composite lamina? Okay, as I mentioned before, for the previous video, I already mentioned that the easiest one to find the center of mass of composite lamina is to draw the x-y axis first. Okay students, please take a look to the xy axis. Students, this one is shape 1, rectangle. The second one is shape 2, triangle. And the third one is shape 3, triangle as well. Okay students, to find the center of mass this composite lamina, we are going to break down the 3 lists of the information of those objects: shape 1, 2, and 3, center of mass, and area. Okay students, now we go to the first object, shape 1, rectangle. This one, to find the center of mass of this object is to draw the first diagonal and the second diagonal. The intersection of both diagonal, we call that center of mass this rectangle. Is it right, everyone? Okay students, center of mass consists of 2 components: x-axis and y-axis components. The first is x-axis components. Look up to this object. We found that the center of mass of this shape on x-axis is a half of 16. It is 8 meters. And for the y-axis is a half of 8 meters. It is 4 meters. It is 4 meters. Okay, so center of mass of this first shape is 8, 4. And the area of this shape is 16 times 8. We found 128 meters square. Is it clear, everyone? Good. Now we go to the second shape. The second shape is triangle. How to find the center of mass of this triangle? Yes, that's correct. We're going to draw 3 lines on this shape. Okay, is it clear, everyone? The intersection points of these 3 lines, we call that center of mass of this triangle. How to find the center of mass of this second shape? That's very easy, everyone. Now for the x-axis. For the x-axis. For the x-axis, we found that it is 8 meters. How to find 8 meters? Yes, correct. A half of 16 meters. Okay, now what about y component? Students, as we know that the center of mass of the triangle by 0, 0 from the base is 1/3 of height of the triangle. Once again, 1/3 of height of the triangle from the base. We found that 1/3 of height is 1/3 times 15. We found 5 meters. But center of mass for the y components will be measured from 0, 0 or by origin 0, 0. So in total, the center of mass of this triangle by 0, 0 or origin is 8 plus 5. We found 13 meters. Is it clear, everyone? Now you're going to fill the table. Center of mass of the second shape is 8, 13. And the area is a half of 16 times 15. I mean a half time base time height. We found 120 meters square. Is it clear, everyone? Very good. Okay, now we go to the third shape. For the third shape, we found this shape is the triangle as well, right? By using the same method, we found that the intersection line is center of mass. All right, we found this as center of mass of the triangle for the third shape. Now our work is how to find the center of mass of this third shape. Okay, students, now we are going to find the center of mass, the third shape, for x components. As we know that the center of mass of the triangle calculated from the base is 1/3 of height. We found that 1/3 of height equals to 1/3 of 12. We found 4 meters. So when we calculated the size or the length of the center of mass for the x components by OO or origin 0, 0, we found that for the x components of center of mass of the third shape is 16 plus 4. We found 20 meters. That's right, everyone? Okay, what about for y components of the center of mass? That's very easy. We found that for the y components of center of mass of this triangle is 4 meters. How you know that? That's right, a half of 8 meters. So, the center of mass of the third shape is 20,4, and the area of this triangle is a half times 8 times 12. We found 48 meters square. That's easy, right, everyone? Okay, to finalize this center of composite object, you're going to use this formula. As we know, this composite object consists of 3 objects. So Gx equals to x1a1 plus x2a2 plus x3a3 divided by total areas. We found that for the x components, 8 times 128 plus 8 times 120 plus 20 times 48 divided by 128 plus 120 and 48 meters square. By using the calculator, we found that center of composite object for the x-axis is 9.9 meters. Clear, everyone? Next, what about center of composite object for the y-axis or y component? Gy is y1a1 plus y2a2 plus y3a3 divided by total areas. By inserting the data from the table, we found that 4 times 128 plus 13 times 120 plus 4 times 48 divided by 128 plus 120 plus 48, we found Gy equals to 7.65 meters. Okay, so we found the center of composite objects is 9.95 meters, 7.65 meters. Is it clear, everyone? Good. Okay, students, I think example 1 very clear. Students, now we go to the example 2. Okay, students, look at this object. What is the shape of this object? Is it symmetry object? Okay. How to find the center of mass of this object? Yes. The first step is to draw the xy axis for this object. This yellow object is not rectangle, it's not triangle, but this object consists of a rectangle and the empty triangle. That's right, everyone? Okay, we can manipulate this object by these steps. Okay, the first we're going to list first shape, center of mass, and area. Shape 1 and shape 2. How you know that this object consists of shape 1 and shape 2? Okay, students, by manipulating this object, we found that for the whole object is rectangle and the empty object is the triangle. Is it clear, everyone? Once again, students, by manipulating this object, we found that this yellow object consists of two objects. A whole object is a rectangle, and the empty object is the triangle. That's right, everyone? Okay, students. Students, the first object is a whole object. You have to imagine this one is the whole object. We can find the center of mass of this object is the center of mass of the rectangle by drawing two intersecting diagonals. Okay, that's right. This is the center of mass. So I think that's very easy to find the center of mass of this object. 6, 10, right? How you find the x is 6 and the y is 10? That's right. For the x component, we found 6 by using the easiest method. It is a half of 12 meters. We found 6 meters. And for the y components, we found 10 by a half of 20 meters. So that's why we found that the center of mass of this whole object for this rectangle is 6,10. Okay, what about the area? That's very easy. The area is the area of rectangle. We found that 12 meters times 20 meters, and the area is 240 meters. Okay, students, now we go to empty object. How to find the center of mass of this empty object or this triangle? Students, as we know that the center of mass of the triangle calculated from the base is a third of height. As we know that the height of this triangle is 6 meters from the base. So the center of mass of this empty object from the base, from the top, I think, right? Is a third of height equals to a third of 6. We found 2 meters. Right, everyone? Okay, as we know, this empty object measure from the origin or 0, 0, yeah? For the x is 12, and for the y is 20 meters from 0, 0. And this one is center of mass of this empty object. Students, measuring the center of mass should be from 0, 0 or respective to origin. By manipulating this empty object, we found that the center of mass for x components is 6 meters, right, everyone? How you know that? Yes, a half of 12 meters. So the center of mass of this empty object is 6 meters, Right, everyone? Okay, now how to find center of mass for the y components. Okay, so start calculating. For the y components, there are two lines. The first from the base and the second one from the top of the triangle to center of mass of this empty object. The first length is 14 meters. Right, everyone? How you know that? 14 meters? Yes. 20 meters minus 6 meters. And the second one is from the top of this empty object to the black dot as center of mass of this empty object. We found that 6 meters minus 2 meters, we found 4 meters. Right, everyone? Okay, next. Total center of mass for the y components of this empty object is 14 plus 4 meters. And finally, we found 18 meters. Right, everyone? Okay, so now we're going to complete the table. Center of mass is 6, 18, and the area is a half times 12 times 6. We found 36 meters for the area of the empty object or empty triangle. Okay, students, now our job to finalize this calculation, center of composite object. The first is gx, x1 or a1 minus x2, a2 over a1 minus a2. Why we have to put the minus? Because this triangle is an empty object. Once again, why we put the minus sign? Because the triangle is the empty object. So gx is 6 times 2040 minus 6 times 36 divided by 240 minus 36. Once again, we have to put minus because the triangle is the empty object. So finally, we found the gx is 6 meters. Okay, now we go to gy. y1 a1 minus y2 a2 divided by a1 minus a2. gy equals to 10 times 2040 minus 18 times 36 divided by 240 minus 36. Finally, we found the center of mass of this composite object for y components is 8.59 meters. So the conclusion, center of composite object is 6 meters, 8.59 meters. Is it clear, everyone? That's very easy, right? Okay, students, now we go to the example 3. What is example 3? This one. Example 3. Look at this object. This object consists of a big half circle and double half circle. Inside of this big half circle, right? Okay, the distance of this big circle is 2r. And the question is find the center of mass of this composite object. Okay, I'll give you the clue. Center of mass of a half circle noted as gx equals to a half r and gy is 4r divided by 3 phi. This is the formula. By 0, 0 or respect to origin point. Okay, students? Okay, this is a half circle. Okay, by drawing xy axis on this half circle, gx is a half r and gy equals to 4r divided by 3 phi by 0.00. Okay, now we go to the question. By drawing xy axis on this composite object, we found there are 3 objects here. A big half circle, that is the yellow half circle. The second one is the empty object. It is a half small circle. And the third object is an empty object. It is a half empty circle. That's right, everyone. So there are 3 objects build this composite object. Okay, now going to list the information from that composite object. There are 3 shapes: shape 1, shape 2, and shape 3. How to find the center of mass of this composite object? Okay, students, now your turn to answer this question. Good luck.